Hi everyone! Welcome to the fourth video in the complete course on Python by Crowd Course Initiative. Today we're going to talk about lists in Python. In this lecture, I'm going to walk you through everything you need to know about lists. We're going to explore the following topics together. Creating lists, like how to create and use lists. What are the common operations that we can perform on lists? What are the functions and the kind of functions that lists have? Lastly, I'll show you some tricks about how you can generate numbers, random numbers, in an array. So what are lists? Think of them like a good old moving box or like a shopping list that you have that contains all the things that you want to buy. Python uses lists to organize information in a structured way. Now let's create some lists. To create a list, we put a number of items within square brackets. Just as we have the freedom to put any item in our grocery cart, Python allows us to do the same. Let's create a list named students having student names in it. So now we have a student, Joe, Mark, and Dave, and you can see they are put in square brackets. You can have items of different data types too, like string and numbers, or even Boolean, all in one single list. Even cats and dogs. Accessing lists. Now that we have created a list, how do we access the specific element in the list? We access lists using indexes. The index in the list is marked from 0. That is how Python does it. Consider the list of students Joe, Dave, and Mark. And if we want to print the student at index 2, what do you think it would be? We would number it from 0, 1, and 2. So we should get the output as Mark. Let's see what Python gives us. Yes, that's Mark. Next, we move on to modifying lists and changing value. What would you do if you had a rotten apple in your cart? You just put it by mistake. You would pick that one and replace it with a good one. Same way, to modify your list, you need to pick up the element from the index position and replace it with a new value. Consider our same list of students, and to replace the student at the second position, index position, that's Mark, with Steve, we gotta give it as student of 2 equal to Steve. Let's see what Python gives us. You see the output? Python actually replaced that Mark with Steve. Easy, isn't it? Let's move on to adding more elements to our list. Say you have a queue of people standing in and you see them, you want to join those people. Where would you join? It's obvious, you would join at the end of the line. Same way, when we add new elements to an array, it gets added to the end of the array. And how do we do it? We could use append or the simple plus to add to lists. And plus behaves like concatenation. So imagine you have the same list of students and you want to append Leo to the list. Where do you think it would come? Try it out in your console. Python gives us the output, Leo joined at the end of the list, just like how more people join at the end of the queue. Next, we will move on to inserting more elements into the list. Say you are at a library and you took out a book and you need to go and keep it back. How do you think you're going to keep it back? You need to know where you took the book from, and you got to keep it back at the same position. In Python, to insert an element, we have to provide the index position along with the element. So if you want to insert the student Leo at the second position in this list, you have to give this index position. So since Mark is at the position 2, and when you insert Leo, let's see what Python does. Yes, Python actually pushes Mark to the 3rd position and inserts Leo on the 2nd position. Just try it out on your console. It's that simple. Let's move on to modifying this, deleting an element from a list. To delete an element, you have to be specific about what element you're planning to delete. Because if you mess this up, you could lose your data. To delete an element, you have to provide the specific index of the element. And you can use the function remove as well, which helps you to remove the element by just searching to the list. So you have the list of student Joe, Dave, Mark, and Steve. So you print out the student list and you get Joe, Dave, Mark, and Steve. Now you want to remove Steve. So you provide the element Steve, and if you try to print out the list of student, you would not find it in it anymore because it searches through the list and it removes the element Steve. Next, when you try to delete a student, you give it as del and you give the index position, which is very important. And when you print it out, you would find that this element at the 0th position is missing. Let's delete the list as a whole. You just give it as student without any index, and you try to print it out right now. That's right, it's an error. Python says it can't find a list named student because it's not defined anymore. Slicing lists. When you plan to slice a list, you need to know what you need. So you've got to slice what you need. Python uses start, stop, and skip when it tries to slice a list. So the start indicates where the index from where you want to start the slicing from. The stop indicates where you want to end with the end exclusive, and the skip indicates by what steps you want to exclude the elements. So you have a list alpha, A, B, C, D, and E, and you want to print from the 1st to the 4th element. So first to the 3rd element. So let's see what happens. Python prints from the element at position 1, that's starting index 1, 2, 3, and it says 4, but it's exclusive, so it would only print till the 3rd index here. So that's why you have B, C, and D. Let's modify alternate elements in an array, skipping. So to skip here, we give the skip index x2. So it skips every 2nd element. So it skips B and it skips D. And you replace the remaining elements with a hash. And so when you print it, you would see there's a hash. Now let's move on to a few important points to note in lists. Say you have a box of billiard balls and it is owned by 2 people, person A and person B. So both are the owners of the same box. Say you remove one ball from this box. What happens? It's obvious that the other person loses a ball too. So say you have a list of box A and box B having colors red, green, and blue. The box A, at 0th element, you replace it to yellow, and if you try to print the other list, let's see what happens. Yes, Python replaces the other list to yellow, green, and blue. Why does this happen? This happens because both the lists point to the same memory index where it is stored. This applies even when we do the following. Say you have the box A of red, green, and blue, and you assign the list A to list B. So now they both point to the same location, and if you try to print the box B, you would get red, green, and blue. Now say you have 2 boxes, but they both look same, but they both belong to 2 different people. And now what happens when you change one of those elements in one of those boxes? They're both the same kind, but it's a different box. Say you have color A, red, green, and blue, and color B, red, green, and blue, and you change the A to yellow. Let's print color A, color B, and color A. Color B prints as red, green, and blue because you never changed it. But color A changed to yellow, green, and blue. So though they both have the same elements, they occupy different positions in the memory. Move on to numpy. So what's numpy? NumPy is an open source Python module which is used for mathematical calculations and manipulations of big array and large matrix operations. So the basic way to import the module once you have installed NumPy is as import NumPy as NP. So you could imagine a list as an array of just like this boxed cupboard. So why NumPy here? So lists in Python, it's similar to lists in Python, but NumPy is much more efficient and flexible. And you can convert any list in Python into an array just by doing list of A equal to np.array of list of A. To find the size of the array, you could give it as list.size, which would give the number of elements, the total number of elements in that array. Shape. You could find it as list.shape, and that will give you the number of rows and columns that are there in the array. It's always written as first the number of rows followed by the number of columns. Type. To find the type of the list of the array that you have, you could give it as list.dtype. You should remember that even though it's written as list.a, it's actually an array here. List functions. Now let's learn some list functions, or you can say more tools, that you could use to manipulate lists and get the desired results. Here I'm going to explain you some of the functions, but there's a lot to be explored. First, let's go to reverse. Reverse helps to reverse the order in a given list. So you have a list 1, 2, 3, 4, 5. And you do list.reverse and you print it, you would get 5, 4, 3, 2, and 1. Length. That's used to find the length of the list. When you print a length of list, you would get 5 because there are 5 elements in your list. Mean. Mean helps to find the average of all your elements in the array. So now you have the array 1, 2, 3, 4, and 5, and you print out the list of mean, you would get 3. Let's move on to finding more tools. Standard deviation. To find the standard deviation, you could use list.std, and that would output you the result of all the standard deviation of all the elements in your list. Square root. Square root of elements in an array is what this sqrt function does. You could give all your elements and it would output the square root of each element in an array. This random number generation. Now, to generate random numbers in an array with NumPy is very easy. Let's take a look at each of these. The first list says np.random.random23. What it does is, it gives you a 2x3 array with numbers between 0 and 1. Let's print it out and see what we get. Here we have 6 elements, and we have each of them between 0 and 1. List that too. It says np.random rand in 10. What it does here is, it gives you an element below 10. Let's see what it gives. It gives the output as 4. It's similar to what list 3 does, where it gives 0 to 10 and you get the output as 9. So the number that prints is between 0 and 10. List 4. It gives you some numbers between 0 and 10, but the size of the list would be 6. So it's a 1D array with 6 elements. There you go. Next, if you want to get a list, but you want a size, say 2 rows and 3 columns, but you want it between 0 and 10, here's what you do. There you go. With that, we come to the end of Python listing and hope you had a good time. So see you again soon. Thank you.